And we're recording. So find the expression used to describe the pattern for the sequence 5, 8, 11, 14. So the first thing you do is, what are my differences? 5 to 8, 8 to 11, 11 to 14. I go up by 3 each time. So it's 3 times n, 3 times 1, 3 times 2, 3 times 3, 3 times 4. And then, are the numbers in this column equal to this column? No, they're not the same. I need to do what? I need to add 2. So I add 2, add 2, add 2, add 2. I check. 3 times 1 is 3 plus 2 is 5. 3 times 2 is 6 plus 2 is 8. 9 plus 2, 11. It works. So my formula is 3n plus 2. That's what I need to see. Okay. Questions? Okay. Number 2 always kills me. The below equations show 4 different properties of multiplication. Each is either inverse, commutative, identity, or associative property. Label using each property only once. So what are my possible answers? I have 4 possible answers. Those are the only answers that might possibly be true. It's going to be inverse, commutative, identity, or associative. It's going to be one of those 4. Nothing else will be legitimate. Okay? Anything else doesn't count at all. You know, if it's not one of those 4, you're going to get it wrong. Okay? So you need to know and understand what the properties are and which. Now, when I multiply and I get the same thing back again, that's the identity property. Second one, they're the same on each side except the numbers have moved. When you move, you commute. This is a commutative property. Okay. When I multiply, what is 6? What is the relationship between 6 and 1/6? 1/6 is the what of 6? Inverse, reciprocal, same thing. I get it back. This is the inverse property. I flipped it over. It's the inverse. Which means the last one has to be what? The associative property. It's how things are grouped. It's the only one that has grouping, so it's the only one that has association. So it's got to be the associative property anyways. Okay, for number 3, you have to give at least one example of each type of number. Okay? An irrational number. A number that cannot be written as a fraction. There are several possibilities, the most common of which is pi that we work with, but the square root of any non-perfect square will work. Okay? A whole number. 0, 1, 2, 3, 4, 5, 6. Give an example. 3. Okay. A rational number is a number that can be written as a fraction. 1/2 is a fraction. An integer is a non-fraction that's positive or negative. -3. These are examples. These are not the only possible answers. Okay? But I do get students that get these ones wrong. That's for an integer and they give me a fraction. Okay, integers cannot be fractions. They can be negative, but they cannot be fractions or decimals. Okay, got to be careful with that. Questions on 2 or 3? Okay, and I mentioned one on yesterday we were talking about this. This is for x equals 3. So plug it in and work it out. I have -3 squared plus 14 times 3 minus 1. What do I do first here? Or I should say, what is negative 3 squared? What is this? Negative 9. Because it's not negative 3 in parentheses. The square only applies to the 3, does not apply to the negative. You must be careful on that. If it had negative 3 in parentheses, negative 3 squared is negative 9. Negative 3 squared is positive 9. There is a huge difference between those two. What does the square apply to? It only applies to what it's directly attached to. The negative in front is not part of what's being squared unless it's included in the parentheses for the squaring. Okay? So this is negative 9. And then 14 times 3, let's see, 30, 42. Right? Yeah, 42 minus 1, right? Yeah. Okay. And then negative 9 plus 42 minus 1. 32. Same idea on this one. So I have 2 times negative 3, or the absolute value of 2 times negative 3 plus 1, plus 2 times 4 squared, plus negative 3 squared times 4. The stuff inside the absolute value must be computed before you take the absolute value. Absolute value bars are like parentheses. You do what's inside them first before you take the absolute value. So 2 times negative 3 is negative 6 plus 1. So I have the absolute value of negative 5 plus 2 times, and that is 4 squared. That's 2 times 4 squared is 16. And then plus negative 3 squared, as we discussed before, it's in parentheses. I'm squaring negative 3, so that one is positive 9. 9 times 4. So I have 5. 2 times 16 is 32. 9 times 4 is 36. 32 plus 36 is 68. 68 plus 5 is 73. Right? Arithmetic is good. I hope. You guys do get to use calculators to do this, just not your phones. Okay. Questions? I move through this pretty quick when I do these. If you need me to stop to explain something, say, Mr. Doris, can you explain? And I will explain. Okay. Simplify. My first step, get rid of the parentheses, distribute the negative 4d. 3d cubed minus 4d times 5d, 20d squared. Negative 4d times negative d squared plus 4d cubed plus d squared plus 2d. And then I look for like terms. 3d cubed, 4d cubed gives me 7d cubed. Negative 20d squared plus 1d squared minus 19d squared. And then plus 2d. Okay. Next one. Order of operations. First thing I do is do the exponents. Negative 3 times 4 divided by 4 plus 5 minus 4 times 2. Mixing an order of operations, multiplication and division at the same time. 3 times 4 is 12. Negative 3 times 4 is negative 12. Negative 12 divided by 4 is negative 3. Plus 5 minus 4 times 2 is 8. Negative 3 plus 5 is 2. 2 minus 8. Negative. Okay, remember multiplication, division at the same time, and then addition, subtraction at the same time. Number 8, write as a mathematical phrase, product of the difference of a number and x and 3. So I'm taking the product of two things. My two things are this and that. So I'm going to multiply those two things. The difference of a number and x, number x and 3. So that means I have x minus 3. That's the difference of a number x and 3. And it's the product of 3 times that. Do not distribute and simplify. If you have something like this, leave it as that, because that fits the description. Okay? That fits the description of what it is, the product of those two things. 3 and the difference of x minus, the difference of x and 3. Okay? It should not be 3x minus 9, although they are equivalent. This is what fits the description of the phrase. Okay. Okay, is the following always, sometimes, or never true? First thing I want to do is distribute, get rid of the parentheses. 7 minus 12h plus 3 equals 6 minus 12h plus 4. Combine up like terms, negative 12h plus 10 equals negative 12h plus 10. I do not need to go any farther. I have exactly the same thing on both sides. If I ever get to a point where I have exactly the same thing on both sides, it's always true. And I don't need to go any farther if I got it figured out by this point, because it doesn't say solve. It says give me always, sometimes, or never. And once you understand which one it is, you answer which one it is. You don't need to go any farther if you understand this one is. If you need to make the next step, which would be add 12 to both sides, so you would get, if you add 12h to both sides, you would get 10 equals 10. Ooh, that's always true. Okay. If you need to make that next step, make that next step. If you don't. Okay. Number 10, solve for E and imp. Actually, solve for C and imp. E equals mc squared. Imp. Solve for C. So first thing I need to do, E equals mc squared. I need to get c squared by itself first. So my first step is to divide both sides by m. So I get E over m equals c squared. Okay, how do you undo a square? Square root. Square root both sides. And you get c equals the square root of E over m. Okay. So the speed of light is equal to the square root of energy divided by mass. Okay. Number 11. If you put down for number 11, there are no mistakes. You immediately got it wrong. It says find the error. I will never give you a problem that says find the error and not give you an error. Now, if I say find the error if there is one, if not say no error, then that might be possible. If I say find the error, circle the first error. That means there might be more than one, but there is an error. Somebody made a mistake somewhere, and there is one. Okay? And your first mistake is that right there. Actually, no, that is correct. My bad. Your first mistake is here. That's what the mistake is. My bad. And if you're not sure where the first mistake is, here's what you do. Work the problem out. So I have negative c minus 3 minus 5c equals 21. Distribute negative c plus 3 equals negative 5c equals, minus 5c equals 21. Negative 6c plus 3 equals 21. Subtract 3. Negative 6c equals 18. Divide by negative 6. C equals negative 3. Which you are supposed to, because it says, and state the correct solution. So I need to have both of those. You have to tell me where the problem is, and then you have to give me the right answer. I love it when I talk about this and I say there is a mistake. Find the mistake. There is one. Guarantee there will be a mistake. And students still on the test tell me, oh, I don't see the mistake. There is no mistake. I must have screwed down. I didn't screw up. There is a mistake. But it happens anyways. Don't listen to me. Okay. Questions? Solve and graph. Not a lot of room here. No big deal. Negative 1 less than or equal to negative 2x minus 5 is less than 3. First step, add 5 across the board. And I get 4 less than or equal to negative 2x, which is less than 8. And divide everything by negative 2. And I get negative 2 and x and negative 4. And I change my inequalities because I divided by a negative. I have to change them both. And then I graph it. Negative 4, positive 2, closed circle, open circle, and everything in between because that's where x is. Solve and graph. I need to see both.
So when it says label your graph, you didn't do it there?
No, that's I labeled my graph. Didn't I label my graph? What are the important numbers? Negative 4 and 2. That's all I care about. No. Seriously, I do not need anything other than the important points. No. That's fine. But yeah, unlabeled would be 2 dots and the line in between. Labeled is where are the important parts. That's it. This is all I need to see. Solve. Does it say graph? No, it just says solve. First step, distribute. 5 minus 6b is greater than or equal to negative 6b minus 8. Add 6b to both sides. 5 is greater than negative 8. Oh, crap. Did I make a mistake somewhere? No. Oh, do I have any variables? No. Is that my answer? No. If your variables disappear, your answer is going to be always or never. Is this always true or never true? It's always. 5 is bigger than negative 8. Okay. This is always. If your variables disappear, your answer is not what you have left. Your answer is either always or never. If your variable is still there, your answer is whatever you get with the variable in it. But if your variables drop out like this, you're going to give me always or you're going to give me never. You're not going to give me this. If you put this in the box, it's wrong. And you will lose a point. It needs to be always or never in this particular case. Variables disappear. This is not my answer. This is not the solution to the problem. My solution is, hey, it's always going to work no matter what you put in for B. It's always true. Okay. Number 14 is always, sometimes, or never true. Same idea, start working it out. Distribute first. 6 minus 12x plus 13x less than or equal to 5x plus 6 minus 7x. Combine up like terms. 6 plus x is less than or equal to 6 minus 2x. And I know where there's always sometimes they're never already. Are the variables the same? Are the variables the same on both sides? I have x and negative 2x. They're not the same. This is a sometimes. If I were to continue, add 2x, 6 plus 2x, or sorry, plus 3x is less than or equal to 6. I could keep going, so I'll just subtract 6. 3x is less than or equal to 0. Divide both sides by 3. X is less than or equal to 0. That would be a sometimes. It's true whenever x is less than or equal to 0. Whenever x is negative, or I should say, whenever x is non-positive, because less than or equal to 0 is not negative, less than or equal to 0 is non-positive. There's a difference. It's true. If x is positive, it's not true. The variable portion was different. The numeric portion was the same. I only care about the numeric portion for always, sometimes, or never if the variables are different. I'm sorry, the variables are the same. They're not. They're different. Don't be afraid of zeros. This is one where I have students get to hear, subtract 6, and they get 0, and they go, oh, crap, now what? Do not be afraid of zeros for your answers. They're lovely. They're wonderful. It's a perfectly legitimate answer. And frankly, we start trying to figure out where the zeros happen. Zeros are an important thing. Where do you get 0? A disproportionate amount of work in calculus is set it equal to 0. Set it equal to 0. Find the zeros. Find the zeros. Where are the zeros? Zeros are extremely important. Do not be afraid of zeros. Okay? They're extremely important. Don't be afraid of them. And I do. I get students, well, it can't be 0. Why not? It can be 0. X can be 0. That can be the only thing is when X doesn't work. Okay. Solve the equation and check for extraneous solutions. Okay. I have absolute value equal to stuff. I have absolute value all by itself equal to stuff. So my first step is to take what's inside the absolute value, 3x plus 1, equal to stuff. And what's inside the absolute value equal to the opposite of stuff. Equal to plus and minus. Okay. Now solve. Subtract 2x. X plus 1 equals negative 5. Subtract 1. X equals negative 6. Distribute the negative. 3x plus 1 equals negative 2x plus 5. Distribute the negative all the way across. Add 2x. 5x plus 1 is equal to 5. Subtract 1. 5x equals 4. Divide by 5. X equals 4 fifths. Is that right? Okay. What do I need to do next? It says right there in the directions what to do next. And check for extraneous solutions. See what works, what doesn't work. Your answer could be both of those. Your answer could be one of those. Your answer could be neither of those. You must check them both to see what works and what doesn't work. It's entirely possible they both work, entirely possible neither one of them works. Plug them back into the original problem. Okay. Take negative 6, put it in here. Negative 6 times 3 is negative 18. Negative 18 plus 1 is negative 17. Absolute value of that is 17. Negative 6 times 2 is negative 12. Negative 12 minus 5 is negative 17. I get 17 equal to negative 17. It's no bueno. 4/5. Okay, 4/5 times 3 is 12/5. 12/5 plus 1 is 5 plus 12. I get 17/5. And you will have calculators. You can make it 4/5 into a decimal and multiply it through on your calculators to check your answer. I don't care. I'm just doing fractions because I like fractions. I'm weird. 4/5 times 2 is 8/5, right? 8/5 minus 5 8/5 minus 5 is, let's see, 5 times 5 is 25. 8 minus 25 is negative 17. Negative 17/5. You know what, I'm working. You know what, I'm working. Happens. Perfectly valid. No solution. You didn't check and assume that because the first one you tried didn't work, that the second one does, you got problems. Okay? Questions? Solving graph. So my first step is to split it into 2. 4k minus 2 is greater than 20 or equal to 27. 4k minus 2 is less than or equal to negative 27. Add 2. 4k is greater than or equal to 29. Divide by 4. K is greater than or equal to 29. Sorry, 29, not 92. K is greater than or equal to 29 fourths. Add 2. 4k is less than or equal to negative 25. Divide by 4. K is less than or equal to negative 25 fourths. So I need to solve, which I did. So I need to put in my box K is greater than 29 fourths. Is this an and or an or? It's an or, and you need to know which one's which. This is an or. K is less than or equal to negative 25 fourths. How do I, oh my God, how do I graph 29 fourths and 25 fourths? Here's how you do it, negative 25 fourths. I don't care about any of the other numbers other than those two. So I don't care where it goes in the number line as long as I get the negative, the smaller one to the left and the larger one to the right. It's pretty easy because one's negative, one's positive. Those are my only numbers. Everything less than that, everything greater than that, or equal to, fill in the dots, or don't fill in the dots as appropriate. Because if you have hollow dots and they should be filled in, you're marked wrong. If you have them filled in and they should be hollow, you will get marked wrong. If you have one of each, I guarantee you'll get marked wrong. And yes, I've seen one of each on these. Okay. Question? Same idea. 3p plus 1 is less than negative 7. 3p plus 1 is greater than 7. Subtract 1. 3p is less than negative 8. Divide by 3. P is less than negative 8/3. Subtract 1. 3p is greater than 6. Divide by 3. P is greater than 2. Is this an and or an or? This one's an and. So it must be true for both of them. So I have 2, and I have negative 8/3. And I have everything bigger and everything smaller. And means they need to overlap. Do they overlap anywhere? There is no particular solution for this. And if you look at the original problem, it makes perfect sense. What is the smallest value, the smallest thing in absolute value could ever be? 0. The smallest in absolute value could ever be is 0. The absolute value of 0 is 0. The absolute value of anything else is larger than 0. Is 0 or anything larger than 0 ever going to be smaller than negative 7? If you look at the original problem, it never is going to work because the smallest I will ever have the absolute value is 0. 0 will never be less than negative 7. Nothing's ever going to work. Absolute value will never be negative, so it will never be smaller than negative 7. So there is no solution just from looking at the original problem without working it out. Working it out just confirms my intuition. Okay? Performance task portion of your test. The performance task is included within your examination. Okay. You're packing canisters that each weigh 3.2 pounds in a crate that, when empty, weighs 12.4 pounds. What is the greatest number of canisters that you can pack in a crate so the total weight does not exceed 26.8 pounds? Okay. So, in the column, and it has top right because that's the way it is on your paper. I have it here because I cut and pasted. There are 2 errors in the solution. Find and circle the 2 errors. Okay. The weight of the canisters plus the weight of the crate must be less than or equal to 26.8 pounds. Yep, that's true. It can be that, but it cannot exceed that. So it can be that, but it can't be any more than that. Okay. Let x equal the number of canisters, fine. So the weight of canisters 3.2 times x plus 12.4 is less than or equal to 26.8. Okay, are we good? 26.8 minus 12.4. Is that 14.4? Is that right? I think this is one where I actually screwed up and didn't have a mistake. I knew there was one. But it's on the practice test, not on the real test. 14.4 divided by 3.2 is not 4.5. So I know that's wrong. Right? What is that? Because I know 3 goes into 14, it's going to be less. 3 going into 14 is going to be less than 5. Right? So I don't know what this is because I don't have my calculator, but I know that's wrong. Since it does not make sense to pack a part of a canister, the final answer is x equals 5. That's also wrong. There are my 2 mistakes. Your final mathematical step and then your conclusion based upon your final mathematical step. 5 canisters is more than 4.5. If I can only have, if this was correct, 14.4 divided by 3.2, is that? Okay. Oh, yeah, sorry. So this is where my mistake is. There are no 2 errors. There's only 1. But this is a crucial mistake. Is it not? Because if my answer is 4.5 or less, 5 is not 4.5 or less. Now I can't put in a half a canister. So what would my maximum be? It would be 4 canisters. I guarantee on the test it will not be 1. I know what happened is when I'm making up the practice test, I had to change the numbers. And often when you do something like that, what you do is you work out the problem correctly and then you put a mistake in it. Forgot to put the mistake in my problem. I know on the real test it does have more than 1 error. Okay, I know it does. On this one it doesn't. But that's because when I was making it up, it's actually harder to make a problem that has mistakes in it. Because you do the problem right, then you put the mistake in it somewhere. Does that make sense? So as a teacher, it's harder to write mistake problems. And that's what I did. I did it correctly, and then I forgot to go back and make a mistake. My bad. Okay, 19, still a performance task. Basketball, the scores determined worth free throws worth 1 point, field goals worth either 2 or 3 points each. Use F for free throws, G for 2-point goals, H for 3-point goals, and write an equation to determine the total number of points scored. So my total equals 1 times the number of free throws plus 2 times the number of 2-point goals plus 3 times the number of 3-pointers. Calculate the total number of combined points scored by the 3 players below. So you get 1 total answer. Does it say you have to use the formula? No. So when you see a question like this, all you got to do is figure out how many points they get. So 1, 2, 3. So there's 4 points here. And then the 2-pointers, there's 5 and 3 is 8. 8 plus 6. So that's 14 2-point goals, which is 28 points, right? And there are 5 3-pointers, so that's 15 points for that. So 4 plus 28 is 32. 32 plus 15 is 47. Now, if you want to take each one of these, put them in here and figure it out, you will get the same total. But it doesn't say you have to do that. You just have to do that right. C, modify the equation in part A above to determine the total number of free throws made given the number of field goals, 3-pointers, and whatever. Blah, blah, blah. In other words, solve so F equals the other stuff. Solve it for F. Take what you got here. Take what you got here, solve for F. T equals F plus 2G plus 3H. Solve for F. That's what that says. Solve for F. Subtract 2G, subtract 3H. T minus 2G minus 3H is equal to F. F equals T minus 2G minus 3H. In another game, Michael scored a total of 21 points. He had 5 field goals and 2 3-points. How many free throws did he get? Or 5 field goals, 2 3-point goals. Should say 5 free throws. How many 2-points did he get? Does that make sense? This is a typo. 5. Yeah, 5 free throws. Okay. So 5 equals 21 minus 2G minus 3 times, sorry, 3 times 3. Although that won't work out either. And I got a typo in there. I can't remember what my typo is now. Yeah, because that won't work out, will it? I got a typo in there. I can't remember what my typo is. So 5 equals 21 minus 2g minus 9. 5 equals 21 minus 9 is how much? That would be 12 minus 2g. So subtract 12 from both sides. Negative 7 equals negative 2g. I can't have an odd number of field goals, or a fraction, I should say. Negative 5 divided by negative 2, or negative 7 divided by negative 2, gives me 3.5, and he didn't make 3.5 shots. Does that make sense? Do you see what I'm saying? I think, no, I don't want to keep, I don't want to, go, thank you. I think that this how many free throws did he make? I think that's what that's supposed to be. So F equals 21 minus 2 times 5 minus 3 times 3. Nope, that doesn't work either. But you guys get the idea, right? I really hate that I have this in here, but you guys get the right idea, right? Okay. You take the information, plug it into the formula. You got the formula is correct. I got typos on the information. Okay, so you guys understand what's going on that one? That one's my bad. It will work out on the test. I've done the test. I've worked the test. When I made this up, I think that's what I did is a couple of typos. Okay? Yeah. 3 times 2. I was reading 3.3. My bad. So F equals 5. And it will work with the other one too. My bad. It will work with doing it the other way as well. My bad. I was reading the 3-point field goals wrong. I read it as 3 of them rather than 2 of them. Questions?